Jai Hind. Today the topic which we are going to discuss is Internet of Things, that is IoT, and it comes under Unit 3 of the with the subject code KCA 101. These are the contents which we are going to cover: introduction, definition, characteristics, then what is the physical design of IoT, enabling technologies behind IoT, IoT architecture, its limitations, and various types of sensors which are deployed in IoT. So basically, what is IoT? If you look at the figure, we are having various devices, and all these devices, they are meant for specific purpose. For example, we are having camera, we are having phone, laptops, we are having smart flower pot, smart you could say mixer, then we are having smart cot meant for baby monitoring, then smart bulb, smart vehicle, smart light system, smart you could say pet accessories. So these are various things, and all these things, they are connected together over the internet. So IoT, this imply Internet of Things. So this term means we are connecting different devices together over the internet. So we could say it is a phenomena which connects a variety of things, and here all these things, they have the ability to communicate, and this particular ability makes them different from their other counterparts which are not able to communicate. For example, we could have mixer that is without this communication ability available in the market. Similarly, we are also having another variant in the market, that is a smart mixers, which have the ability to communicate over the internet. So these are the few definitions of IoT. One is from Wikipedia, and this is the general definition we could say. So what is Internet of Things? It is also termed as Internet of Objects, basically refer to a wireless network between objects. Usually the network here, it is considered wireless, self-configuring, such as household appliances. So this is the definition which is provided by Wikipedia, but we are having two main definitions adopted in 2008 and another one adopted in 2020. In 2008, what the IoT mean? At that time, this definition says the term Internet of Things has come to describe a number of technologies and research disciplines that enable the internet to reach out into the real world of physical objects. That is, in 2008, the Internet of Things, this term is basically focused on the technologies. Sorry. The technologies and research disciplines with the help of which the internet is connecting all these physical objects together. But in 2020, what we are having now, that things have identities, that is, they each and every device in the IoT network is having its own identity, and this identity makes them or give them virtual personalities operating in smart spaces. And how they are operating in smart spaces? Using intelligent interfaces to connect and communicate within social environment and user context. So now the IoT is primarily focused on these particular context, and here the devices, the research is more how to make all these devices autonomous and how these devices can communicate with one another without human intervention. So on the basis of the last definition, what are the basic characters of IoT? It should be dynamic and self-adapting. That is, according to the context, it could adapt itself, and all these nodes, they can come and join the network at their willingness. Self-configuring, configuring, that is, if some particular thing want to join the network, then it can be easily configured without the help of the human. Interoperable communication protocols, as we have seen in the previous figure, that all these devices, they are heterogeneous in nature. So we are having different technologies with the help of which they are communicating over the internet, and that is the reason they are having different protocols on which they are communicating or on which they are operating. So if we want to create a IoT network, for example in a smart home, so we are having different devices. So here all these protocols, communication protocols, they should be interoperable in nature. All the devices, they should have the ability to gain the unique identity. And what this term means? This term means that all the devices, they have the ability that we can assign IP address to them. If we are able to attach a IP address with a particular device, then we can uniquely identify it. And all the smart devices which are present in the IoT, they are having the ability to get IP address. Integrated into information network, that is, they are able to get attached to the network easily. Heterogeneity, as we have already seen, that all the devices, they are heterogeneous in nature. There is no constraint over the type of devices. Even if we are having a same type of device, again this particular feature or particular characteristics is there. For example, in your home you want to install smart bulbs. So maybe the possibility in one of the room you are having the smart bulb which has been manufactured by some other vendor. In other room, maybe your smart bulb, it has been manufactured by other vendor. Then in that case also, although both the bulbs, they are termed as a smart bulbs, they are smart in nature, but still, since they have been manufactured by different vendors, so they might be having different set of protocols inbuilt in them. They may be having different chips with the help of which they are communicating over the internet. So heterogeneity is always there. Dynamic changes, that is, the state of the devices change dynamically. What the term state means? State means, for example, we are having a sensor which is detecting the intensity of the light. So as soon as you are switching on the light, or that sensor has been deployed in the outer environment, then according to the intensity of the sun, it is operating. In the night, it is not operating. So at that time, the device, the sensor which has been integrated with that particular device, is in the mode of sleeping. It is sleeping at that time. So as soon as the first ray of the sun fall on that particular sensor, it has to wake up. Similarly, we could have other states also of the devices. For example, we can suspend it according to the change in the environment, or if it has been suspended, then we can resume it. So these are the various states of the devices, and they all change dynamically because they are sensing. The sensors has been inbuilt in all these devices, so they are sensing the environment. So as soon as they sense a change in the environment, their state got changed. So on the basis of this, another important characteristics is sensing. That is, they should have the ability to sense their environment. Another and the last characteristics is safety. Safety should be inbuilt in all these devices. Since they have to be connected on the internet, so there must be some safety feature which should be included in the IoT system. These are the few application domains and scenarios. We could have IoT applications in transportation and logistics, healthcare, smart environments, personal and social sector, and some futuristic applications. In the transportation and logistics, we are having logistic, assisted driving applications, mobile ticketing, environment monitoring, augmented maps. Similarly, in healthcare, we are having devices which are keeping a track of the health of a person, which might help in identification and authentication of health records, data collection, sensing. In smart environments, we are having smart homes, smart offices, smart industries, smart museum, smart gyms. So these are the few applications where we are having smart IoT applications. In the personal and the social care, we could have social networking, historical queries, losses, thefts, etc. In the futuristic, we could have robot taxis, city information model, and your enhanced game room. In the shopping, this figure is simply showing the scenario in a shopping mall. So here, if you look at the figure, when you enter the shopping mall, then the doors automatically got open. So they are scanning. Similarly, if you are taking the items, then again the doors, you might have sensors and they can scan if some tag is still on the clothing. Another thing, when shopping in the market, the goods will introduce themselves. This is another application which can be implemented in a shopping mall, that when you are visiting a rack, then the items on those racks, they are introducing themselves, okay, I am so and so product, and so on. Similarly, when you are moving the goods, the reader will tell the staff to put a new one. Maybe if the rack goes out of stack, then that particular stack can send alert to the staff that particular item has got out of stock from that particular rack. Another thing, another IoT application in the shopping complex, it could be when you paying for the goods, the microchip of the credit card will communicate with the checkout reader automatically. Another scenario is your healthcare. Various sensors, we are having various sensors for various conditions. For example, this is your glaucoma, we are having glaucoma sensor, then we are having intracranial pressure sensors in the brain, we are having cochlear implant, bladder and bowel electrical simulators are there. Then we are having sphincter sensors, activity monitor, functional electric simulation for limb motion, then retinal implant, and so on. So, for example, in intracranial pressure sensor, that is ICP sensor, short or long term monitoring of pressure in the brain cavity is being observed, and it is implanted in the brain cavity and senses the increase of the pressure. Sensor and associated electronics encapsulated in safe and biodegradable material, and we are having external RF readers which power the unit, and it receives the signal, and generally the stability is over 30 days so far. So we are having various health sensors which are being wearable devices which are based on these sensors in the healthcare industry. Another thing is national, for example, National Health Information Network. It keeps a record of the electronic patient record, which again we are having home care monitoring and control devices, for example, pulse oximeters, blood glucose monitors, etc. We are having operating room of the future, that is here the closed loop monitoring and control can be done. Multiple treatment stations are there where multiple doctors from different countries, they can collaborate on the same platform. Plug and play devices are there. We are having robots which can perform the micro surgeries, system coordination, but in this case system coordination is a challenge, but there are various applications which are already have worked on this particular aspect. Then progress in bioinformatics, for example, gene, protein expression, systems biology, disease dynamics, control mechanism, All these are few other you could say other sectors of the healthcare industry on which IoT applications has been built upon. This is your smart home, and we are having various smart devices which are interconnected with one another. We could have smart meters, smart cooling system, smart temperature regulation systems, smart appliances, smart security systems, etc. And if you look at the figure here, all these devices, they are connected with the internet, and through internet we are being connected over the cloud. Another scenario is your transportation. A network of sensors set up throughout a vehicle, it can interact with its surroundings to provide valuable feedback. That is what is the condition of the local roads, how is the weather of that particular area, what is the traffic conditions of that particular area to the car driver, so that the car, it can work on auto mode, and it provide adaptive drive systems to respond accordingly. This may involve automatic activation of braking systems or speed control via fuel management systems. Condition and event detection sensors can activate systems to maintain driver and passenger comfort and safety through the use of airbag, seat belt, pre-tensioning. Sensors for fatigue and mood monitoring are also now being deployed in smart transportation or smart vehicle system. This is another area where the sensors are being heavily deployed. For example, monitoring the environment. There are certain areas where the human reachability is minimum, and at that particular area we can deploy the sensor network, and with the help of those sensor network we can predict the change in the environment of that particular area. Now the next thing is how the physical design of IoT being carried out. So the things in IoT, it usually refers to IoT devices which have unique identities and can perform remote sensing and actuating and have monitoring capabilities, as we have seen in previous slides. So IoT device, it can exchange the data with other connected devices and applications, and it can be done directly or indirectly. It collects the data from other devices and it can process the data locally. Now the processing, it could be done in both ways, locally, or it can send the data to centralized servers or cloud based network where the processing of the data can be done. So perform some task locally, so it performs some task locally, and other task within the IoT infrastructure based on temporal and space constraints. So the things, we are having two kinds of things in the IoT network. One is physical thing and another one is virtual things. When we are saying physical things, then it exists in the physical world and they are capable of being sensed, actuated and connected. Examples are your industrial robots, goods and electrical equipments, etc. Whereas in the case of the virtual things, they exist in the information world and they are capable of being stored, processed and assessed. That is, it is the data or information. So the examples include multimedia content, application softwares and so on. So if you look at the figure, we are having physical world and information world. So in the case of the physical world, this is your IoT device and this is your physical thing. Here we are having, this is your white colored boxes, they are your gateways. These are the virtual things, as we have seen earlier. We are having physical things and virtual things. So this is physical and this is your virtual thing. And here we are having various, you could say, lines. So we are having a dotted line for communication and the light colored lines, they are meant for mapping the physical device with the virtual devices or virtual things. We are having three kinds of communication. This is communication via gateway A communication, that is here you could see here this particular thing is communicating with this, and the gateway is involved in this case. Another concept is communication without the gateway. Here again the thing is through internet, but without the involvement of the gateway. Maybe it is the internal network and no gateway is required in this case, local servers you could say. Then another one is your direct communication, that is these two things without the involvement of internet. Maybe they are not they are on wireless or short range communication connections, and on which they are communicating. So this is a direct communication. Here if you look, all these physical things, they can be mapped one to one with a single physical virtual thing, or they can be mapped to various virtual things. Another important thing to understand in IoT is any X point of view in IoT. That is, with the IoT you can get any X point view. What it means? It means it is the IoT devices, the processing can be done anytime and in any context. It can be done or it can be used by anyone, anybody, any service, any business. They can use the IoT, any path, any network. Again, there is no restriction, wireless or wired. In the case of IoT applications, they can be deployed, IoT application, they can be deployed any place, anywhere, and they can work on any device. That is heterogeneity of device, is support to the heterogeneity of devices is there. Now, what are the enabling technologies behind the IoT? Because so far we had understood that IoT is not a pure discipline, it is a combination of various disciplines, or you could say it is a intra-discipline approach. So we are having various technologies which are responsible for the development of IoT. The first thing is RFID, and basically RFID, it is being used to identify and track the data of things. Then there is a development in the sensors technology. Why we need the sensors? To collect and process the data to detect the changes in the physical status of a thing. Then we are having other smart technologies, for example, and why we require these smart technology? To enhance the power of the network by developing processing capabilities to different part of the network. Then there is another field which is very important, that is nanotechnology. We need this particular technology to make the things smaller and smaller, and moreover they are being made smaller, but still they have the ability to connect with the internet and interact with other sensors or with other devices. RFIDs, the reduction, it is basically, if you look at the figure, we are having computer, we are having reader or interrogator, and here we are having this reader is having a antenna, and this is your RFID chip. It is sending some signals, and these signals being detected by antennas, and once the antenna detect these signals, through your connection, it will send those signals to the computer, and computer, it can perform action according to the application. So the reduction in terms of size, weight, energy consumption and the cost of the radio takes us to a new era, and this allows us to integrate radios in almost all objects, and thus to add the world anything to the above vision, which leads to the IoT concept. Composed of one or more readers and tags, RFID tags is a small microchip which is attached to an antenna, can be seen as one of the main smallest components of IoT that collects the data. Another important thing is wireless technologies, because as we have seen that various kinds of devices, they got connected over the IoT network. So here we need the wireless technology, and the wireless technology, when we say wireless technology, then initially we are on the telecommunication systems, and it is the initial or the primary service where we use mobile voice telephony. Here we got large coverage per access point, for instance 100 seconds of meters, but the data rate is low and moderate in this case. Example is your GSM, UMTS, etc. Then from telecommunication systems we move to wireless LANs. Initial service is your wireless Ethernet extension. Moderate coverage per access point is generally 10 second to 100 second per meters. Then we are having moderate or the high data rate in this case. Example is IEEE 802.11 or WiMAX. Another wireless technology is a short range. Here the direct connection between the devices, which we basically use when we form a sensor networks. It is typically low power, and examples are your Bluetooth, Zigbee, Z-Wave, which is Z-Wave is primarily used when we form a smart home network. Other examples are your satellite systems, which we need for the global coverage, and the applications are your TV broadcast or positioning or personal communications. We are having broadcast systems where we use satellite and terrestrial support, fixed wireless access, for example your DECT, WLAN, etc. As we have seen that in IoT, to form IoT network, we have to form a sensor network. So it consists of certain number which can be very high of sensing nodes, and these nodes, they are communicating with other nodes or with the network wirelessly. So moreover, they are communicating in a multi-hop fashion. We require this particular thing, multi-hop fashion, in the case of wireless sensor networks. So if you look at the figure, we are having a layer 1, and these are at the layer 1 we are having low end sensor nodes. At the layer 2 we are having high end sensor nodes. Now these low end sensor nodes, they are connected with this high end sensor nodes. If you look at the figure, this particular network is connected to this single high-end sensor. That is, if you want to make a large sensor network, then in that case we can form the large sensor network with the help of low-end and high-end sensor nodes. After that, at the layer 3 we are having sync nodes, and these sync nodes, they can be static, they can be mobile in nature. After that, these sync nodes or the mobile static or mobile sync nodes, they can send to the data to the low-end computational devices, and these low-end computational devices, they can be your mobile phones as the simplest low-end computational device. Then now this mobile device, if it requires a complex computation and it can't support that complex computation, then it can send the data to high-end computational devices, which can be your laptop or your desktop or any internal server of that particular organization. If we want to make a global network, then these high-end computational devices, if they require the support from other high-end servers, then they can communicate over the cloud. So this is how your sensor networks, they can communicate over the cloud with other IoT applications. Sensor nodes generally exist without IoT, but IoT cannot exist without sensor networks. That is, to form IoT network, we require sensor nodes, or you could say sensor networks. Sensor networks, it has been developed, designed and used for specific application purpose. For example, it could be your agriculture, it could be your environmental monitoring system. So for IoT purpose, sensor nodes need to have a middleware addressing issues, data, how we do the data fusion, how the scalability, security, QoS support can be done. IoT, when we talk about the IoT layered architecture, we are having, there is no general agreement over it. We are having 3-layer architecture, we are having 4-layer architecture. Initially, we are having the 3-layer architecture. If you look at the figure, we are having application at the top and perception layer at the last, lowest layer you could say, and this is the middle layer, that is a network layer. In the 4-layer, we are having all these 3 layers, but we are having another additional layer, that is the support layer. Whereas in the case of the 5-layer, we are having a perception layer and your application. Above application, we are having business logic layer, and in the middle, we are having processing layer and the transport layer. So this is your perception layer. It comprised of your RFID surveillance cameras, that is your things. Network layer is your wireless or wired network, and application layer, it could be smart home, for which particular things have been deployed. It could be smart homes, wearable device, hospitals, and so on. So in the case of the support layer, 4-layer architecture, support layer is the additional one. And the reason to make a 4th layer is the security in the architecture of the IoT, which is being missed in the case of 3-layer architecture. Whereas in the case of the 5-layer architecture, we are having additional processing, transport, and business layer. Why we require the Internet of Things? For the dynamic control of industry and daily life, improving the resource utilization ratio, better relationship between human and nature, and to form an intellectual entity by integrating human society and physical systems. What are the challenges in case of IoT? Technological standardization, managing and fostering the rapid innovation, privacy, security, and the absence of governance. Sensors, in this figure you can have various types of sensors. We could have sensors for acceleration, motion, temperature, humidity, acoustic, flow, force, leaks, and so on. We are having 2 types of sensor. One is active and another one is passive. Active sensors, they emit energy of their own and then sense the response of the environment to that energy. For example, your radar system. Whereas in the case of the passive energy, they simply receive the energy, they cannot emit the energy, and on the basis of it, it can sense the environment. For example, your temperature sensors. These are the few sensor types: position, occupancy, velocity, acceleration, force, and pressure, flow, radiation, temperature, chemical, biosensor. These are just the name of a few categories of sensors. These are the references which you can go through for further study of IoT concept. Thank you and Jai Hind.